Procedo Orchestra, and welcome again to Pantas Malaya. So, in relation to uh, platform technologies, so we're going to talk about now how we can optimize the execution time of interconnected devices. In platform technologies, we are dealing with uh, computer architecture as well as the computer uh, organization. So this two is the main component of how we can optimize the execution time of the interconnected devices. So we are going to build faster machines. We are going to improve the current computer systems, current computing devices, to make it work as to double or triple faster than the previous versions. Okay. So today we're going to talk about that, how we can optimize, how we can do that. So first, I am presenting to you the diagram of a computer organization and architecture. As you can see in the diagram, we have the outer layer, which is the we have the input, we have the output, we have the memory, and then on the much inner part of the diagram are the ALU, control unit, and the instruction set architecture. If we talk about how a computer works, it feels like the instructions that the central processing unit will be performing will come from the input. For example, from the user, it could be from a keyboard, a mouse, or something like this, a mic, or a camera. That's the input. And then, how can that input commands can be processed inside your central processing unit? It can be processed with the help of the instruction set architecture. So the instruction set architecture is it's like a software that could handle another software. So in your computer, if you have personal computer, the best example is your operating system. That is not the entirety of the instruction set architecture, but it is one of the biggest example in the part of the instruction set architecture, the operating system, because your computer may or will not work according to its users if there is no operating system. Now from the input, the instructions will run through the instruction set architecture, and it will be processed inside the central processing unit with the help of arithmetic logic unit, or the ALU. But then these processes will be managed by the control unit. So the memory will only be accessed if the commands needs to retrieve or store information or resources into your computer's memory. So these resources will be used in the processing of central processing unit for the commands in order to produce an output. So from input, run through instruction set architecture to the ALU control unit, and then keep or retrieve from the memory, and then produces an output. So the main use of control unit is that it manages the processes between input, instruction set architecture, output, and the memory, as well as the arithmetic logic unit. So it will manage the traffic processes, which will be which of the job will be first to be executed, the second, the third, and the last. So in optimization, so with this idea, with this concept, how can we optimize? How can we make our machine faster? No. Firstly, we have to understand what are these parts. So if you say memory, these are the RAM, the random access memory, and then the ROM, or read-only memory, as well as the cache. Cache is a type of memory which could be found inside or alongside the central processing unit. So, while the arithmetic logic unit, or the ALU, is a major component of the central processing unit, which is divided into two. First one is the AU, or the arithmetic unit, and then the second one is the logic unit. AU is the one responsible for adding, subtracting, dividing, multiplying. So it is more on a mathematical job performance inside the central processing unit, while the logic unit will deals with the true or false, yes or no, and other logic representation of the outcome, the process. While the control unit directs the operation of the processor, so it tells the computer's memory, arithmetic logic unit, and input and output devices how to respond the instructions that have been sent to the processor. It directs the operation of the other units by providing timing and control signals. So as like what I have said a while ago, the control unit acts as the manager between these peripherals, between these parts, the input, output, the memory, ALU, the processor, and the instruction set architecture. If we talk about instruction set architecture, so in computer science, an instruction set architecture, or ISA, is also called the computer architecture. So, a device that executes instruction described by that ISA, such as central processing unit, is called an implementation. So the processes happening in the central processing unit is an implementation of the instruction set architecture. So in general, an ISA defines the supported data types, the registers, the hardware support for managing main memory, fundamental features such as the memory consistency, addressing modes, the virtual memory, and input-output module of a family of implementation of ISA. The best example is the operating system. So if you have operating systems, it will utilize all the connected devices in your computer. It will facilitate the instructions from the input, transfer to the central processing unit, let the control unit take a hold of the processes, and then let the ALU performs the specific jobs between arithmetic and logic, and then utilize the memory for storage, retrieval, and storing information as per instruction set architecture, then produce an output to the output devices with the help of instruction set architecture. It is much likely that the instruction set architecture will translate the input into a computing machine language, then take the result and reprocess the result, resample the result to make an output that is understandable by the user of the computer. So it is like an intermediary person between two parties, the instruction set architecture. And in our computing machine, the best example is the operating system. So how we optimize? So how can we, now that we know all those things, how can we optimize our computing machine? First of the three that is most commonly looked into when optimizing a computing device, a computing machine, is by increasing the capacity of the memory in its circuits. So memory, the RAM, we will increase the capacity from 1 gig, 2 gig, 4 gig, 8 gig, 16, and we times it by 2, the capacity of memory per computing machine. As well as if we talk about circuits, that would be the processing, the processor. Will improve the processor's capability. It's like what happened to the current era of computing devices like octa-cores, Core i7, Ryzen 9. So those circuits, those central processing units has greatly improved through the help of computer architecture planning. And then the second one is by increasing the speed or algorithm. So since our computing machine is tasked to solve simple to complex problems, there are certain algorithms proposed by previous mathematicians in the history and now applied in the computer science, applied into the processing of instructions in our computing machine. So maybe if we can augment, if we can improve the algorithm, so let's say an algorithm that runs by 60 seconds can be reduced to 30 seconds. If we can do that, we can utilize, we can improve, we can greatly optimize the performance of a computing device, of a computing machine. So by computing machine, I didn't only mean those personal computers, laptops. We also take note on the smartphones, tablets, notebooks, okay? And by improving the efficiency and performance of the peripherals. So say for example, in the previous versions of computing machine, especially in personal computer has only has a big hard disk drive, but the capacity of its storage is very low. It only caters MB, megabytes. But now we have Tera. So in the later years, maybe we can improve Tera into another billions or zillions of capacity. Also the RAM. So these peripherals, if we can optimize or improve these peripherals, then we can greatly improve the computing machine in the future. That is the main purpose of studying platform technologies, to understand how machine works, how computer machine works, so that we can optimize, we can utilize the machine up to its top limit. Okay, so since we are talking about the uh, platform technologies, we will now first discuss the importance of having an operating system. So if you can see on the screen, we have here some of the logo of the most popular operating systems. So the first one in blue, we have, that is the Windows, so the most commonly known as Microsoft Windows. Now we have the Macintosh by Apple, then Android for from Google, and then we have the Ubuntu from Linux. Among these three, it is only the Linux that is free. Okay. Then, if you talk about operating system, it is a program that after being initially loaded into the computer by a boot program, manages all the other application programs in a computer. The application programs make use of the operating system by making requests for services through a defined application program interface, so or API. So just like what I have said a while ago, it is like an intermediary, or a link between our computing device peripherals and the human, the user of the computer. So it will let you communicate with other devices, and inside the computer, the operating system, it will allow such devices connected into the computer to send and receive information. So operating system can be defined as an interface between user and hardware. So they say it is responsible for the execution of all the processes, resource allocation, CPU management, file management, and many other tasks. So that is the main concept of having an operating system in your computing machine or computer. Okay. So in addition, users can interact directly with the operating system through a user interface, or GUI, such as command line interface, or the CLI. So there are at least two, CLI and GUI. In the previous versions of computer, it has the CLI, the command line interface. But as of this generation, it is already in a GUI, a graphical user interface already. Previously, computer, you could only see a screen with black and white text, black background white text, or blue background white text. But now you can have buttons, text, images, etc. Those are the graphical user interface. Here's a diagram of a computer system. So we have three layers. The first layer is the application software. So an example of application software are computer games, internet browsers, databases. If we put that example into your smartphone, we have with computer games, we have those ML, we have the Facebook Messenger, the Facebook app, YouTube app, whatever other application that you have installed in your smartphone. If we go to the operating system, it is now with the utilities or the system software. So the system software are those software that runs in the background to facilitate requests from the application software and between the hardware. So this utility software will allow hardware to work with the application software and vice versa, dependent on the command that is given by the user itself. Now if you say utilities, some of the example of utilities is that when you have your computer and you have bought a new printer, that printer, when you attach the USB cord in your computer, you will not automatically be able to manage the full capacity of that printer, not unless you have installed the driver for that printer. Now that driver is the utility. It is the API or the interface between that peripheral and your central processing unit or the operating system itself. So hardware, operating system, application software. So these three layers of the computer, computing machine, computing device. So there is a question of why use an operating system. It is because with the help of operating system will bring most powerful benefits to computer software and software development. Without an operating system, every application would need to include its own user interface, and we don't need that. We don't like that. We want to utilize what is already in the package of the software or the operating system. So we'll only provide the code for the commands as a programmer, and that code will utilize what is already packed in that operating system as user interface. So we will only utilize those libraries, as well as the comprehensive code needed to handle all low-level functionality of the underlying computer, such as a disk storage, network interfaces, and so on. So we don't need to deal with the high level or the very logical implementation of how computer works, but just on the low level functionality of the underlying computer. So we'll see a button, we'll click that button, something will happen, but we don't really it doesn't really matter to us what is the actual code of that button. So that is the good thing about operating system, or having an operating system. We don't need to deal with the logical implementation or the code itself, but just the functionality of it. So this is the structure of a computer system. Okay, so we have these users, the people who are using the computer, me, you, us, the application programs, which are the compilers, databases, games, video player, browsers, etc. Any other application that you have installed in your computing device or computing machine, those are application programs. And then we have uh, system programs, the shells, editors, compilers. This system programs works within the system itself. We directly communicate with the system. If the application is a finished product, it's something like a finished product for the user to use, like games. A system programs is a program that is give you access to mid-level implementation of the logical part of the computer. So it doesn't really the actual code, or you are going to do some coding, but um, it is closely related into the management of the operating system or the computer as a whole. Then the operating system, a special program which acts as the interface between user and the hardware. So how can we communicate with a printer? How can we communicate the other peripherals using our keyboard and our mouse? So the operating system lets you do that. So it will detect the mouse movement, it will detect the button pressed in the keyboard, it will submit those instructions into the central processing unit, the ALU, for logic operation or logic implementation, or the arithmetic counterpart, to produce an output. So the one that is doing that is your operating system. Another part of the um, computer system is the last part of the computer system is the hardware. We have this example, the CPU, a central processing unit, the katong pinakagamay na chip. We have the disk, we have the memory, etc. Any other physical implementation, any other physical peripheral or device that you have seen attached into your computing machine or computing device, that is what we call hardware. Okay. So the components is divided into at least three major parts: the user end, the system, and the hardware. User communicate to hardware via the help of the system. Inside the user, we have the users itself, the application programs, and then on the system we have the utilities and the operating system, and on the hardware part we have the machine language will interpret the commands from the user that is compiled or interpreted by the system, and then the microprogramming, the logical part of bits and zeros, the true or false, or the logic gates of commands, the logic commands to the hardware that will utilize the full capacity of your central processing unit, the CPU, the memory, or the input and output devices. So what does an operating system do? First, it will process management, process synchronization, memory management, the CPU scheduling, file management, and security. So these are the important things that operating system do. In terms of security, if we talk about security, there are between Microsoft and Apple, there are files that can't be directly opened directly in if you transfer it to the Macintosh or Apple softwares. So if you have some files from Microsoft Windows, you cannot directly open that in Macintosh Apple, because of that specific security imposed by the Apple company. File management almost the same, CPU scheduling almost the same with computers, the memory management, process synchronization talks about the algorithm, and process management talks about the algorithm. So the basic organization of a computer system is something like this. So if we see, from the input unit comes the instruction. That instruction will be stored in the storage unit, the RAM or ROM or cache. Then it will be sent to and from the arithmetic logic unit for the process inside the central processing unit, and whatever the result of that operation or process will be sent back to the storage unit before it will be displayed in the output unit as a result. So So but along the line, along this transition, or the 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 transfer of data and information, as well as the processing of job of work, it is being controlled by the control unit. So it is being managed by the control unit, from the input to the processing during the inside the central processing unit, as well as in storing and presenting the output into the as a result into the output devices, peripheral. So if you say input, it accepts or reads instructions and data from the outside world. So example of the input devices are mouse, keyboard, mic, microphone, camera, and then it converts these instructions and data in computer acceptable form. So instead of from my voice that is transmitted into the microphone will be converted into a series of bits, series of zeros and ones, or the binary system that is the only language that our machine could understand. And from that, when the result is being processed, resample, it will create another like MP4 file and output it as an audio. It supplies the converted instructions and data to the computer system for further processing. Say output, it accepts the results produced by the computer, which are in coded form and hence cannot be easily understood by us. It converts these coded results to human acceptable readable form. So say for example, just like what I have said, my voice is the input into the mic. It will be converted into a machine language, a series of zeros and ones, and then after processing, it will be converted into an MP4 file or MP3 file, so that we could hear an audio output from the computer. Same as like the camera, the stream that the camera receives from this session will be converted into a series of zeros and ones as binaries, so that the computer can reassess the information and data, and then recompile that data and produce an MP4 or MPEG version of the stream, so that we can see a video output from the camera. So it supplies converted results to outside world. It is output unit. Example of the output unit is your computer monitor, speaker, printer. And if we talk about storage unit, it is the data instruction required for processing. So received from input devices, then an intermediate results of processing, final results of processing before they are released to an output device. It's just a storage, a container of data or instructions or informations that need to be processed and produced as an output. So there are two types of storage. First is the primary storage and the secondary storage. If you see primary storage, it talks about for example, the random access memory, or the one you call a memory card. So all other informations that is all other informations that needed to be stored, like this, while I am recording this presentation, this discussion, the current file is not saved in my hard disk drive, but it is just temporarily saved in a primary storage or in my RAM, in my memory card. Not unless I end this session, it will be recompiled and reprocessed and resampled, and then be saved to the secondary storage. So if this is secondary storage, it is the storage that is permanently save information, like your hard disk. So further explanation of the primary or differentiation of the primary storage and the secondary storage is that if we say primary storage, it used to hold running program instructions, used to hold data intermediate results and results of ongoing processing of jobs. It is fast in operation but small in capacity. It is expensive, volatile, losses data in power dissipation is possible. So if this current session, then there is a power interruption, the recording will be automatically will be vanished, will be lost from the primary storage, not unless if the software I am using is capable of saving a copy in terms of power losses, sudden power interruptions. And then if talk about secondary storage, is used to hold stored program instructions, used to hold data information in stored jobs. Slower than primary storage. It's slower, but has a large capacity, a lot cheaper than primary storage, and it will retain data even without power. So that is the secondary storage. If we talk arithmetic logic unit of a computer system, it is a place where the actual executions of instructions takes place during processing of the operation. So it is the one, let's say, it is the mind of the computer, the computing device. So it will process the logical part, the arithmetic part of the instructions or the process, while the control unit is the manager. So it will manage and coordinates the operations of all the components of the computer system, while the central processing unit, or the commonly known CPU, it is the brain of the computer system. So it is responsible for controlling the operations of other units of a computer system. So we can say that this arithmetic logic unit is uh, the laborer. Then we have this control unit as the manager, and then the central processing unit is the planning division. The control unit is the planning division, and then the central processing unit is the manager. So central processing unit, management; control unit, the planning; arithmetic logic unit, the labor. This is the brain. This is the implementation, and this is the actual work. And there are at least 6 major components of the operating system. We have the file management, process management, security management, secondary storage management, input and output device management, as well as the network management. These 6 major components of the operating system will be discussed in our next video. So for today, this will be the end of our discussion. So if you have something to ask, a question, a query, or clarification, you can comment down below, and we'll try our best to answer your questions and inquiries. Thank you.